All right, so page 5. Hello, Tanner. Welcome. Hey, Tanner. Everyone says hi. All right,
Well,
he's not dead, or he wouldn't be online. I'm just guessing. All right, everyone, look for a second at page 5. Today's a little bit tricky. I want you to have page 5 available. Page 6, you're going to write stuff right here. Okay, so we're gonna do notes on page 5. I'm going to do a bunch of demonstrations today and tomorrow, and those on the bottom half of page 6, you record your observations. And then if you would have your naming schemata out, we're going to talk about this box, which we've never talked about before. So the box on the, well, it's pointed out right here, the bottom right-hand corner of your naming schemata. And we're going to teach you how to use that box while we do these notes. Sound all right? All right. Lots of demos today, so I'm going to be messing around with my camera and whatever. We'll see how it goes. So we are going to learn about 5 different types of reactions. They're in the notes on page 5 and 6, but they're also in this box, which is super nice because this box you get to use on the test. So the 5 types of reactions are right here. Today I hope to at least get through the first 3 of them. They are composition, decomposition, single replacement, double replacement, and combustion. Easy enough? All right, then we'll talk about this table more as we go along, but let's just go ahead on page 5 and dive into the notes. That's not working. It's a good start. Okay, fine. Whoa. Oh, that was interesting. I don't know how that happened. Here we go. All right, so this is on page 5. Now, most of page 5 you can follow and fill out just from the box that's on your naming schemata. So right there on page 5, we're going to learn how to classify a reaction as one of the types. So by the end of tomorrow, we should be able to look at any of the reactions I give you and determine its reaction type. So all those ones we've been balancing, there's always been that line in front that said reaction type. We're going to learn how to fill that in. Okay, so the first type of reaction we're going to learn about is a combustion reaction. Sorry, no, a composition, my fault, reaction. And that's when 2 or more simple substances, usually elements, react to form a new substance. All right, these are all matching terms. Every one of them are matching terms. Now, you can sort of, it's one of those days, hold on. You can sort of use, oh, I want this. These models right here, because you'll be able to use that on the periodic or the test, right? You can sort of use that to deduce the definition. It's when 2 or more things combine to make a new substance. So you have to know the definition. You have to know how to figure out which is which as well. All right, so here's an example. R plus S goes to RS. We are just making one product. Another example is calcium sulfide. We take calcium, we add sulfur, and we make calcium sulfide. Now, page 6. The first demonstration I'm going to do for you over here in a second is this demonstration. So where it says demonstration, visual observations, that's where you will draw what you see. Where it says reaction type, you can go ahead and fill that in. Demonstration number 1, the reaction type is a composition reaction. So on page 6, right off the bat, we write composition. That was not very pretty. Hopefully yours looks better. It does. All right, then underneath this, the chemical reaction, that's where we're going to balance it. And I had it on the previous page, but I'll just write it again. The chemical reaction, I'm going to take magnesium. I'm going to add oxygen, and it's going to form magnesium oxide. Now, I have a question I want you to answer with your friends. And it needs to be more than just Jared and Odessa. Here we go. How come I did not put a 2 right there? Isn't oxygen diatomic? Well, you have that short discussion. Why is there no 2 if oxygen's diatomic? Ready, go. Huh? You don't know? How many of you do not know? 1, 2, 3, 4, 5, 6, 7, 8. That's a failure of teaching, not a failure of students. Things are only diatomic when they're alone. So when we read the word oxygen, is there anything else with oxygen? No, it's just oxygen. But oxygen doesn't like to be alone. So it's like a girl going to the bathroom on a date. They're going together. All right? But now, when oxygen's with something else, it doesn't have to share with itself. It can take from magnesium. Okay, so things are only diatomic when they're just by themselves. So that's why there wasn't. All right, will you balance this all out? You probably already have, but if not, go ahead and balance it. And then I'll show you the demonstration over here. It's a nice demonstration. Oh, I already had it over here. It's like over a week away. We still have to do all this. We have a couple labs and we have to apply math. So, well, I don't know. It might be about a week from today. All right, so here we go. Let's see if I did this right. We're going to go to preset 4. Oh, I did it right. I wrote it down. I cheated. Don't even worry about it. All right, so in this reaction, I've already cut a piece. I have just a piece of magnesium, which is just this shiny metal. It's really thin. We've used it a lot in this class. It's really malleable. Just bent it right there. All right, so we just have this one single piece of metal, which is magnesium. Now, I need to react it with oxygen. Where can I find oxygen? In the air. Now, I can let this just react for the next 2 years, and we can watch this process happen. But no one wants to do that, right? So I'm going to add heat. I'm going to light it on fire. Okay, just a 2-year time lapse of it turning grayer. Yep, that'd be fun. All right, guys, let's watch this turn gray. All right, well, instead of that, let's light it on fire. Whenever we burn something, we are simply reacting it with oxygen. Okay. Now, it is super important that you don't stare at this reaction. You can look at it, but don't stare. Well, it would be really dumb for the rest of the hour. Sure, you can do that.
Oh gosh, don't stare at it.
All right, don't stare at it or you won't see the rest of the lecture today. But you can sense there's some stuff being given off, right? Ooh, how pretty. Okay, when it goes out, come back and look. Oh, it already fell. Gosh dang it, it already fell. All right, I'm just going to put that down there. Then turn the lights on for me, would you? All right, notice now it's just a gray substance. Go ahead and hit both of them. Top one, too. So we have this gray powder. Let's see here. Number 5, there we go. So this gray stuff right here, that's the metal that didn't burn, but the rest is just this nice gray, chalky, super dry powder. Okay, yeah, go ahead. All right, magnesium oxide is not super useful, but if you've ever been in the weight room and you've used the chalk, that's what you got. If you look at my hands, they look gross and dry now, right? I am super ready to bench press, which I actually don't do. I'm super ready to watch kids bench press. Let's be realistic. It's what we call a desiccant. It helps things to dry out because it absorbs water, and it makes your hands feel super, super dry. It's super gross, actually. Okay. I was going to ask before he raised his hand what we call the white powder, but then he named the white powder. What was it? The magnesium oxide. Okay, write your observations. Back right corner, yes. The back right corner of that corner. James. Hi, James. Good. How are you doing? All right, good. All right. A composition reaction. Sorry. Okay, cool. It's the only time you look cool when you run. Okay, sorry. That was rude. Yep. When you're just I can't wait. All right. Okay, listen. I don't say always very often in chemistry because chemistry is kind of rude like that and it's not always, but this is an always. A composition reaction always produces just one product, only one product. That's kind of our like red flag that if we see a reaction that only produces one product, meaning only one side of the right, or sorry, only one thing on the right side of the arrow, we have a composition reaction. If you look at the example, one product, one product, one product. I didn't ever balance this, by the way. It should be a 2, a 1, and a 2. Who had that right? Okay. Composition is when we bring things together and they stick together. So any guesses what a decomposition reaction is? It's the opposite. Okay, so back to page 5. Page 5 is a decomposition reaction. A decomposition reaction is when a single compound is broken down into 2 or more simpler products. All right, so this time, if you look at every example, one reactant, we'll do the one here in the lab in a second, or demonstration, one reactant, sorry. It's one thing that breaks down into 2. So like a composition reaction would be making this remote. A decomposition reaction would be like throwing it against the wall and breaking it. All right, what's that? No. Decomposition reactions in chemistry are way more complicated than composition reactions. Because composition, you just take 2 things and put them together. Decomposition, it depends on what the thing is, on how it breaks apart. So for instance, if I threw my remote against the wall, or I threw her water bottle against the wall, the reaction or the end would be different, right? It's made out of different parts. In chemistry, the formula will tell me how the thing will break apart. It's sort of complicated, but luckily you have the notes for that. And we'll do a demonstration in a minute, but there are 5 ways that reactants break apart. A metallic carbonate, if you add heat, will decompose into metallic oxides and carbon dioxides. So like if I had K2CO3 and I heated it, it'd make K2O, a metallic oxide, and carbon dioxide. These are what you have in fire extinguishers because they're a powder that you spray on a fire. It produces, or it uses the heat to produce CO2, which puts the fire out. It destroys the oxygen around it. All right, a metallic hydroxide, that would be like NaOH. If you heat it, it makes a metallic oxide and water. And those are pretty tricky to balance sometimes, but you just need to know the formula of the compound to know how it breaks apart, and then just follow these rules. A metallic chlorate, this is the one I will demonstrate. So you take a metal like KClO3, a metallic chlorate, you heat it, it makes metallic chloride and oxygen. Metallic chloride and oxygen. Then, whoops, move this out of the way. Some acids, when heated, decompose into non-metallic oxides and water. Some oxides, when heated, just decompose. This bottom one, it just means like if I had barium oxide and I heated it hot enough, it would make barium and oxygen. It just breaks down into its two parts. The acids aren't super common, but if I had like HCl, and it's in water is why it's tricky, it could break apart into HOCl and water. Those are really tricky. So we don't really do those, but that is a way. Okay, the demonstration, back to page 6. Number 2, the chemical reaction type, reaction type is a decomposition. A decomposition reaction. Okay. The one I'm going to do, I already wrote, but it is, I'm going to write it bigger, but it goes right here. It's KClO3, that I'm going to heat it, and it produces potassium chloride and oxygen. That oxygen comes out as a gas. All right. Now, this reaction would be super boring if I didn't spice it up a little bit. All I would do, I would take a white powder and I would heat it and I would convert it to a white powder, and oxygen gas would just be driven off. So that's boring. So to spice things up, I'm going to do this in a test tube. I already have the powder in, and I'm going to put some wood sticks in here. The wood sticks will get hot enough back here in the fume hood that they start to burn. Wood is made out of carbon, hydrogen, and oxygen. It's like cellulose is its technical name. So that carbon, hydrogen, and oxygen bonds are going to be broken down, and they'll release heat. Now, we know in order to burn something, we need oxygen, right? Inside this test tube, I'm going to have a supply of pure oxygen. So they should burn a lot hotter than your campfire. Campfires are red and yellow. If I do this right, we should get white light, which means it's a lot hotter. All right, so go ahead and balance that real quick. All right. So you are welcome to come back by the fume hood. You're welcome to watch it from the TV. I'm going to zoom the camera in. Let me stop share. Just don't be right where Ethan's head is. That's okay. So you'll see the angle that you don't want to block. What I'm going to do is I'm going to take this test tube. So if you want to come back by the fume hood, come over to this side. I'm going to take this test tube, and I've already added potassium chlorate to it. I don't know, can you see that on the screen? Nope, you can't. I've already added potassium chlorate to it. I put in some matches, but I'll put in a few more sticks. And then I'm just going to heat it. Now, at first it's kind of boring because I'm just having to melt the white powder before it will actually start to decompose and produce the oxygen. So just for a bit, I'm just going to heat it, and you'll be bored, but eventually it gets going pretty cool. Sound all right? Okay, good. Go ahead. Yep. All right. So once again, it will take a minute or two. If you heat the glass evenly, it's way less likely to crack. In my career, I've broken one. In Bert's single day of teaching this, he breaks 5. All right, it's hard to see, I'm sure, but there's a little bit of liquid at the bottom. So it's starting to get a little bit closer. It'll still be a while though. Oh, come on. Get to the bottom. All right, so that is that. Go ahead and write that down. One got a little bit stuck, as you probably heard me tell it to go down. All right, so write your observation. Could you guys hear it very well? Okay, we'll talk about that here in just a second. My hands are so gross, I'm gonna wash them. They're just hyper dry. Not even close. All right. Yes.
So is thermite what is it, like composition reaction because it gives off energy?
Nope, this one gave off energy too. Thermite is actually, what we're going to talk about here in a minute, a single replacement reaction where we have aluminum and iron oxide, and they switch to aluminum oxide and iron. Gives off a ton of heat. Okay, so That noise you could hear was this wood burning in a pretty tight test tube, and it was forcing air out of the back, not air, forcing stuff, mostly the burning wood fumes. So carbon dioxide, water, and other things were coming out the back. So what we sort of made right here was a rocket. It literally is exactly the same process for making a solid rocket, or sorry, solid fuel rocket motor. We took an enclosed space, that's the test tube. We took what's an oxidizer, or something that produces oxygen. We put in a fuel, that would be the wood, and then we lit them on fire. And that noise literally is the sound of a tiny little rocket in my hand. Now, it doesn't push very hard. The shaking, that was me. But there was twice where it did push away from me when it tried to eject the wood pieces. And that's kind of when it got stuck too. So when we're right by a rocket motor manufacturer. They are literally making and doing this exact same thing. They don't use potassium chlorate though. They use ammonium perchlorate because it gives them, in the balanced reaction, it gives them one more extra oxygen than this does. Okay, now notice all of these decomposition reactions start with one reactant and produce two products. If I go back, whoops, it was this way. One product, oh, I said it wrong. One reactant, sorry, two products. One reactant, two products. If you look down on the thing that's on your naming schemata, decomposition, one reactant, two products. If you read it as a sentence, a metallic carbonate when heated, there's your one reactant, here's your two products, oxides, carbon dioxides. C is what we did, a metallic chlorate. When heated, decomposes into two products, metallic chloride and oxygen. So the key to composition is one product. The key to decomposition is one reactant. You okay with that so far? Okay, I hope that is good. We will go over these in the homework in a bit, but next we'll talk about the third type of reaction, which is a single replacement reaction. Like, oh, I thought he looked good. All right. In a single replacement reaction, atoms of an element, so not a compound, the atoms of an element replace the atoms of a second element in a compound. These are also not too hard to recognize if you just sort of look how the model fits together. You have a single element that reacts with a compound. What it does is it replaces, the single element will replace one of the elements in the compound. And that element now comes out and is alone, and you have a new compound. You all right with that? An example is when you add copper and silver chloride together. Silver likes to be alone. It doesn't want to be with chlorine. So when copper comes along, the copper will switch places and the silver comes out all by itself. Now it seems like this one's the unhappy one, but it's not. Silver likes to be alone. So copper replaced silver in the chloride to make copper 2 chloride and Ag. A single replacement reaction, if you sort of get it and you can see the model, will always have a single element on both sides of the arrow. It's the only type that has a single element on both sides of the arrow. All right. Now, there are 4 ways that this process happens. The replacement of a metal in a compound by a more active metal. This is the one I will demonstrate here in a minute. Next is the replacement of hydrogen in water by metals. We've seen this early this try when I put sodium in water. The sodium replaced hydrogen in water to produce sodium hydroxide, and it released hydrogen gas. We'll show you another video of that coming up in a minute. Replacement of hydrogen and acids by metals. We've done this a lot. Whenever I've shown you when bubbles were produced, it was usually by that reaction. And letter D, we don't see as much, but that's when a halogen replaces another halogen if it's more active. And we did this in a lab forever ago. Well, not forever ago, but a few weeks ago. We made chlorine gas, and it went around to all these blobs, and it made them change colors. Does that sound familiar? All right, so some of them went brown, and so that meant chlorine was more reactive. So we took Cl2, plus Br2, it was NaBr, not Br2, to produce NaCl plus Br2. Chlorine replaced it. All right, these are, once again, not too hard to recognize. They always have a single element on both sides. All right, the demonstration is this. I'm going to put iron and copper 2 sulfate together. So let's write this out together, not in words. This is supposed to be a 2. Oh, I know I did it. It would be so it's harder to balance. So that's why I did that. Let's stick with that, being a little trickier to balance. Okay, so you don't have to write the words. This is on page 6 again. So iron is what symbol? Fe, good. Then copper 2 sulfate. Remember, the Roman numeral is the charge of copper. So I have Cu sulfate. We find that on the naming schemata is SO4, and it has a -2. If the charges up here are equal, what do you do? Nothing. They cancel each other out. By the way, I forgot to mention, if you remember a random fire drill last year, that was that demonstration I did. My fume hood wasn't working, but I did it anyway, which I'd done before. For some reason that day it set the alarm off, and everyone got 10 minutes off the first hour. You're welcome. It was snowing, so that was kind of the downside. You remember? My bad. I apologize. All right, iron 3 sulfate, and like I said, this is a lie, but we're going to pretend it's true. Iron 3, that'd be a +3. This is a -2. So Fe2 SO4 3 plus copper is all by itself. Okay, will you try and balance that? See the difference, Cohen. What? Yeah. Actually, probably not. That'd be bad. This is bad technique, but I'm going to do it anyway. I don't know that this will show up on camera very well, but we'll go for it. Ooh, I don't remember which one that is. I didn't. Oh, did I write it down? Ouch. Oh man, I never wrote it. Oh, I did. I did. Tom Davidson to the rescue, but I got to stop share. If they would just hire me a professional cameraman every hour, life would be so much easier. Okay, I don't know. It's as good as it's going to get. Sorry, Tanner, if you can't see that very well, but what I have here, I have a paper clip that I unwound it, and then I filed it a little bit to make it less shiny. I'll go around, don't worry. Yep, I have not had that bad of knee issues, but I sprained my knee a long time ago playing football, and they suck. All right, so it's just a normal paper clip, and this is just what we call copper 2 sulfate. So the paper clip is the iron. I filed it because they put plastic around it. Oh my friend just had a baby today, I guess. I haven't talked to him in 2 years. All right, so iron, the blue liquid that you can see right there, that's the copper 2 sulfate. It'll make FeSO4 and copper. So I'm just going to put this in pretty quick, and then I'll take it back out. I don't know if you can see that very well. You see it already turned black. All right, I'll just put that back in and leave it. You can't see a ton until I walk around. You can't even see it at all. So Tanner, sorry, I'm just going to walk around so people can see it a little bit better. All right. So you can see it's definitely changed color. All right. I'm going to put it back in. So definitely changing color. Kind of blackish, almost a little bit starting to turn brown. All right. There you go. Definitely a change, right? That's right, all right, so definitely turning. I'm gonna shake this a tiny bit to get the stuff to fall off. Do you see that stuff falling off, Amber? Yeah. Okay, that stuff falling off is something. I'm gonna ask you what that is. What color would you say that is?
Brown.
Brown. It was black a minute ago, right? All right, so tell your partner what you think this stuff is. This black stuff that's turning brown. Ooh. All right, black stuff turning brown. What do you think it is? Take your best guess. All right, I have a guess for rust. I'll bring this over to the people that were here. You'll see it's now brown instead of black, right?
Okay.
Okay. Now, I'll just leave that in there. Well, I don't know. You can't see that very well. You can see my arm hair pretty good. That's disgusting. You're welcome for that. Okay, I've heard one guess. The brown stuff is rust. Any other guesses? Yeah, everyone agrees that it's rust? Well, you shouldn't, because it's not rust. Nothing against anyone guessing it was rust. Is rust in our reaction? No. It has to be, whatever this brown stuff is, it has to be in our reaction. What on this screen are we familiar that looks kind of light brownish reddish? Copper. Copper. So that paper clip is being coated with copper. It's sticking to the outside. That's why I was kind of able to tap it and have it fall down, sort of like precipitation. That copper sticks to it. It can also be wiped off. I'll show you. So my hands are mostly clean. I say mostly because they're not perfect, but you can see now it's a lot more brown than it was. But the copper's just sticking to it. Not as brown. And there it is on my fingers. This is just copper. Oh, I'm trying to be so cool. And ooh, It feels kind of good, actually. Copper is really small, so it fills in the pores. And then your fingers feel like they have no fingerprints. Maybe I could go rob a bank right now. But then it shows like every crack you've ever had in your life in your skin. Okay, I can put this back in, and I can repeat this process until the solution turns light greenish blue. What do you think the light greenish blue solution is? Iron 2 sulfate. I know there's a 3, but I did that just to make it harder to balance. All right, now look at this example. A single element here, a single element here. Okay, now, real quick. The person that just texted me, his brother is in this slide. What a world we live in. When I was in high school, I had, unfortunately, a single replacement reaction happen to me. I was dating Shannon. I was Tom. This is Andy. I went on a trip out of town for Christmas, and I came back, and Andy was here, and Shannon was right there. And where was I? I was depressed. All by myself. All right. We've all been there. If you haven't, you will. It's fine. Made me a better person. Okay, thanks for being awesome. We will see you tomorrow.
See you, Davidson.
All right. Tanner, I hope that went all right. I'm going to, let's see. No, I don't. I'm just going to stop the recording.